is a have a vertical motion question. Okay, just going to highlight some key parts of the question. Suspended again. Suspension means a tension question. All going to be about tension. Length 2D. It's inextensible, which is what we expect. There's not going to be any k values and like repelling back upwards. That's not going to happen. And one is fixed. Particles released from rest. AB makes an angle alpha with the downward vertical through A. When B has risen again to a height so that AB makes an angle of 45 degrees. So we're talking about here, aren't we? And then with the downward vertical, the midpoint of the string, midpoint, this is going to become very important, comes in contact with a small peg. If cos A equals a quarter, find in terms of D the speed of the particle at the moment that the string touches the peg. Okay, so Control G, and then just move it up here, be a bit more space efficient than usual. Now, here's what's happening. Is a horizontal motion or vertical motion, guys? Vertical motion. Is it R value or T value? T. There's no surface supporting it. Now what's going to happen is you're going to go all the way down, you're going to go across, you're going to hit the peg here, and you're going to stop. That's for part A. You got to find out how fast are we going when this happens. Okay, find the speed when this happens. Okay, and we're going to work on our cos angle first. Okay, so we're just going to bring it over the corner here, and we're going to have alpha equals here. Alpha equals a quarter, so 1 over 4. By Pythagoras' theorem, you can find out that's root 15. So you know sine alpha equals root 15 over 4. I don't even think I used that. Cos alpha equals 1 over 4. Okay, what are the two equations I'm going to use? Let me tell you what the two equations I'm going to use. No, that's horizontal. I'm going to use conservation of energy, and I'm going to follow that by centripetal acceleration. Usually I'd do that. Okay, I went on autopilot and I didn't realize that I had the question answered before I even got to centripetal acceleration. You'll see it as it happens. Okay, so I'm going to start off with conservation of energy anyway. So P1 equals K1 plus P2 plus Ke2. So all the energies, right? So NGH, guys, how far am I above? We need to pick a reference point. Anybody tell me a good reference point to pick? Maybe the bottom of the circle. Good idea for a reference point, isn't it? Okay. So what I'm going to do is first of all I'm going to work on this. I'm going to call this part here. We're going to work on the triangle AB, and we'll make a horizontal line across. Call it AB. I don't know, ABD. Are we happy with that? ABD we're going to work on. So A, B followed by D. Dot dot dot. Now it's angle alpha. This is ln 2D. What I want to find out is I'm looking for vertical distances. How do I know I'm looking for vertical distances? Potential energy is mg, your height above ground. I have to find out what is this red distance here. Everybody happy with that? That red distance there is the same thing as 2D, take away whatever my green distance is. So I have to find out what the green distance is. Okay? So ABD there. So I'm going to find out this here actually corresponds to the green distance. It's going to be 2D cos alpha. Cos alpha is a quarter. That's going to make it D over 2. What's 2D minus D over 2? 2D minus D over 2, anybody? 3D over 2. So that distance there is 3D over 2. No, yes. here to here. I am. It's 2D for the full thing. I can't just see. That's easy. That's 2D. Okay. And then what I have to do is I have to shorten it up by that amount there. And that's what I calculate over here to be d over 2. So it's 2d minus d over 2. Okay. So it's kinetic energy at the beginning. Huh? Why is it 0? Says the word rest. PE2. Now, PE2 is what, guys? PE2. Just a quick note about this. See centripetal acceleration? You usually do that. That usually involves an mv squared or something like that. The centripetal acceleration formula is always set. It's 9 times out of 10. It's set at the end of the question, so you always work with the point at the end of the question, not at the start. That sometimes can be quite confusing and people go wrong there. But anywho, what's your potential energy in the second one? How high are you off the ground this time? We're this high off the ground, aren't we? So what is that distance going to be? We draw a new triangle. Our new triangle is going to be this one here. If I just do this, it's going to be this one here, and this one here. Okay, so it's 1, 2, 3, and I'm trying to draw this triangle here, and I'm finding out this distance here, and once again this distance here complies with this distance here, and we're trying to find out how high are we above the ground. We're trying to find out the blue distance. So it's going to be 2d minus whatever that red distance is. It's going to tell me how high I'm off the ground. Because remember, once again, it's mg, your height, your current height above ground. So it's 45 degrees. That's 2d. That's going to be 2d cos 45. Anybody tell me what 2 cos 45 is? It's going to be root 2d. Okay. So guys, root 2d. Everybody happy enough with that? Okay, so root 2d. So what we're going to do next is mg root 2d. Oh, sorry, that is root 2d, but it's technically 2d minus root 2d. That makes sense? So that's what's going in here. Root d, 2d minus 2 root 2d, and then finally kinetic energy over here. You're going to be moving, aren't you? You're going to be moving with a velocity. So what's that going to be? Half mv squared. Okay. Now, once again, goal of the question: get the speed. Isolate v. This is going to be horrible. Now, I'm going to multiply everything by 2. I just want to get rid of those fractions straight away. So, or put everything over 2 more so. So it's going to be what's it? 3 mgd over 2 equals, we're going to change that to a 2 and then a 2 on the bottom. Alright? So it's going to be what's it? 4 mgd minus 2 root 2. Is that right? 2 root 2 mgd all over 2 plus a half mv squared. Now the 2's are going to cancel. We're going to bring the 4 mg over to work with the 3 mg. That's going to give me minus 1 mgd. The 2 root 2 is going to move over on its own there, and it's just going to become what's it going to become? 2 root 2 mgd as well. And then the other one's going to be mv squared. Now what can leave first? The m's can disappear. I can set g equals 9.8. Okay, and what I can do next is I can just plug in 9.8 for g. Is that alright? So I'm going to plug in 9.8 for g, and the m will disappear here. So I'm going to get phi squared equals 2 root 2 multiplied by 9.8 multiplied by d minus 9.8 d. I'm going to multiply all that out except for the d. I'm going to square root the answer, and I'm going to get phi equals 4.233 root d. Is everybody alright with that? I kept it in surd form. It was a complete nightmare. Okay? So just doing the decimals got me the same answer. It's much easier. Okay? Now that you've done that, what happens here, guys, the only piece of information I need from this, if I remember correctly, is the actual only piece of information I need is the answer. So I can get rid of all that and just keep the answer there. Okay? So if you look at the next part, we usually do centripetal acceleration, but we've already answered the question, so there was absolutely no need whatsoever. And find in terms of the tension of the string when the particle reaches the same height as the peg. Now, here's the tricky part. I'm gonna rub out all of this. Does it reach the same height as the peg? We're talking about the blue rectangle on the bottom, not on the top. Starts here, goes across. It's currently at a height below the peg. Would you agree with that? It's currently this high in the air while the peg is this high. Now, do you want to know what actually happens here, right? Yeah. It hits the peg and loops around it. If you ever have a weighted, like a conker or something like that, when it hits something, it lassos around it or loops around it. So this is what's actually going to happen. Okay, so when it hits the peg, I'm going to draw I'm going to draw this green part to represent the bottom part of the string. The bottom part of the string is now going to do this. It's going to undergo its own mini arc from where it got hit. So in effect, it's going to do something like this. It's going to be what was it? Something like, oh, can't even fit that in. So it's going to do something like this, and it's going to undergo its own mini circular motion. Still vertical circle, but it's going to undergo that path at the point C, and its radius is just going to be something like this, and it's just going to go up and around like that. Is that alright? Now, so we have to set up a new system for ourselves, okay? So I'm going to draw a quick small diagram of what's going on here. So at the point C, we hit it with initial velocity. What's our initial velocity? This guy here, isn't it? We hit it with that velocity there. Okay, and then it hits C. Well, I'm going to start using regular. Hit C, and now it's going to undergo motion until it's at the top. Okay, so what we're trying to do is we're trying to figure out is how much higher do we need to go. Okay, it was at 45 degrees at the very top, wasn't it? If you extend that picture onwards, it was at 45 degrees earlier today, wasn't it? That was 45 degrees. You can see it at the top of the question. Therefore, this angle here is also going to be 45 degrees. So what I can do is I can make this 45 degrees, and I can call the very bottom, I'm going to call the very bottom potential energy equals 0. I'm setting a new reference point for potential energy equals 0, because I can restart the question from the bottom, and then all I have to do is work my way to the top. So what's the current length of this here? It was 2D, but we're told that C was the midpoint. So its length, D. Okay? And next thing, it's going to lasso around, so we're going to get 45 degrees here. That makes this D sine 45, which is D over root 2. Okay? We could go for the centripetal force, but let's stick with our usual routine. Usual routine being conservation of energy, followed by centripetal if we need it. So we're going to go for PE1 plus KE1 equals PE2 plus KE2. I'm going to call this VS, velocity at the start, and then if we're still travelling upwards, we'll call that VE, velocity at the end. So you're currently going Vs in this direction here. You go upwards. Are you going to gain pace or lose pace? Are you going to gain speed or lose speed? Anybody tell me? You're going to lose speed, aren't you? Okay. Now some of you are wondering, how did I even come to the conclusion to actually do this? Okay, would be a decent question to ask. So what I'm going to say is this: find in terms of m the tension in the string when the particle reaches the same height as the peg. So technically speaking, if I drew this line here, going from here to here, what's the only thing keeping that moving in a circle? The tension in the string. The tension in the string, and we started down here. The tension in the string going inwards. Tension equals centripetal force. Centripetal force equals mv squared over r. Tension in the string equals mv squared over d. Everybody right with that? That's as much as we can get. I have to find out what mv squared is, otherwise I can't complete the question. So I have to find out what is mv squared. The only way to find mv squared, or technically mv, it'd be mve squared, it'd be the velocity at the end of the question, not at the start. The only way I can do that is that information is locked up here, and I have to use the conservation of energy to unlock that. Okay? So potential energy at the start of the question we said was 0. It's a half m vs squared. We're just going to leave vs squared as it is for a minute. No point putting in all those decimals and root signs right at the beginning. Then we're going to get a p2. How high are we off the ground at the end of the question? D over root 2. mgd over root 2. And then kinetic energy at the end, a half m v e squared. Okay, the m's cancel. That's one thing down. The next thing is, can we get rid of the root 2's and the 2's on the bottom? What can we multiply everything by to get rid of that? Multiply both sides by 2. When you multiply a half by 2, it cancels into vs squared. What happens when you multiply 1 over root 2 by 2? It ends up to be root 2. Because 2 divided by root 2 is root 2. So what we're going to have here is that's going to disappear, and I'm just going to have root 2 GD. And then this one here is going to be plus VE squared. Okay. Next thing, I can substitute in my value for 4.233 root D squared for my Vs. I'm going to take away my root 2 GD, but instead of G, I'm going to use what? Got to use 9.8. And then that's all going to be equal to phi squared. Put all that into the calculator, and I'm hoping you'll come out with phi squared equals 4.06D. Okay. Do I need to isolate V on its own? Look at what I have highlighted in the top right hand side. I just needed to get the phi squared, didn't I? So my T value equals my M times my phi squared value, which is 4.06D, all over 4.06. Not over 4.06, over D. And then look what happens. The D's cancel, and we get T equals 4.06 M, and that's your tension.